Hi there. Today we're going to be looking at percentage of a quantity. We're going to start with expressing a quantity as a percentage, and secondly we're going to look at calculating the percentage of a quantity. So let's start with expressing a quantity as a percentage, and I'm going to show you two different methods for this one. So firstly, if I had let's say I had 40 muffins, and of those 40 muffins, 8 were chocolate muffins. Okay, so I want to work out the percentage of muffins which are chocolate. So I know that 8 of my 40 muffins are chocolate. So 8 are chocolate out of a total of 40. Let's see how I can do this. I'm going to show you two different methods. Okay, method 1, we're going to use equivalent fractions. Now you will recall from our previous lesson on percentages that we talked about percent means out of 100. So one option is to create a fraction, an equivalent fraction, with a denominator of 100. Let's see how we can do it with this one. I've got 8 over 40. It's a little bit tricky, isn't it? Because I've got to think about how I can get from 40 to 100. Let's start by simplifying it. So I know, if nothing else, I know that both of these numbers are even numbers, and therefore I can divide them both by 2. You probably can see that something else I could do as well, but let's just start with that. That would give me 4 over 20 by dividing the numerator and the denominator by 2. If I do it again, because I've still got even numbers, 4 and 20 are both still even, I'm going to end up with 2 over 10. Now that's not my fraction in its simplest form. I could keep going and I would end up with 1/5. But because I'm trying to get to a denominator of 100, then I'm going to stop there, because I know that if I multiplied 10 by 10, that's going to give me 100 as my denominator. And if I do the same to my numerator, I'm going to get 20. 20 out of 100, which is 20%. Okay, now what you could have done is you could have seen when you got to 4 over 20 that I could have multiplied by 5 to get from 20 to 100, and 4 multiplied by 5 gives us 20. But if you can't see those quicker steps, then just break it down, take your time until you find one that works. Let's look at that same example, but this time I want to show you a different method. Okay, and this one we simply multiply by 100. So let's look at this. I'm going to use the same numbers. So I start with 8 over 40, and I'm going to multiply by 100. Now you may recall, if you looked at my fractions lessons, that I write 100 as 100 over 1. That's just to make sure I don't make a mistake when I multiply it out. 8 multiplied by 100 gives me 800. 800 over 40 multiplied by 1 is 800 over 40. I'm now going to use my equivalent fractions here, and I can see that both of these numbers are divisible by 10. That's going to give me 80 over 4. So I've divided both my numerator and my denominator by 10. And now I'm going to divide by 4, because I know that 80 is divisible by 4. And that gives me my 20%. So two different methods to get the same solution. Okay, I'll do one more. I'll do a slightly easier one, I think, because I probably started off being a little bit hard. Okay, so let's have a look at one more. So you'll often get one, say, for example, I've got 7 chocolate biscuits. We've got a bit of a theme going on here. In a selection box of 20 biscuits, and I want to know the percentage that are chocolate. Now with something like this, I might be able to go in straight away. I don't need to simplify or do anything with my fraction. I just go straight in, and I know that I can use equivalent fractions to make 100 the denominator. To get from 20 to 100, I need to multiply by 5. 7 multiplied by 5 is going to give me 35, and therefore I have my 35%. It's always great if you've got 2 methods, because you can use the second method to check the answer that you got using your first method. So now let's try method 2, multiplying by 100. 7 over 20 multiplied by 100 over 1. That gives me 700 over 20. But one thing I didn't talk about here, and I know we have mixed opinions on cross-cancelling, but I just want to remind ourselves that I can simplify diagonally here, because I know that both of these numbers are in the 10 times table. I might actually be able to say that they're both in the 20 times table, but if I know they're in the 10 times table, I can simply divide 100 by 10 and 20 by 10. So I'm now going to get 70 over 2, which again simplifies to 35%. So it's really nice if you've got 2 different methods. You can check your own work. You don't need me to be checking it for you. Okay, let's look at another example. Let's look at comparing one number against another. So let's say, for example, I wanted to buy a car, and I've got a choice of car A, which costs £4,000, or car B, which costs £5,000. And I want to know the percentage cost of car A relative to car B, and the cost of car B relative to car A. Now this one is really important, and if you can try and commit this to memory, it will really help you. So we're going to work out how much is car A as a percentage of car B. So I need to do car A, which is £4,000, as a percentage of car B, which is £5,000. Now, I need to multiply this by 100. This is method 2, multiplying by 100 over 1. Now, this time I don't have to worry too much about cross-cancelling, because I can just simplify this here, and hopefully you can all see I can simplify that down to 4/5. So I've got 4/5 multiplied by 100 over 1 gives me 400 over 5. So car A costs 80% of the cost of car B. But what's really interesting is if you do it the other way round. So if I said to you, how much is car B as a percentage of car A? If we were in a classroom, I would say, is it 120%? And I would say, do you agree? Do you disagree? And then we'd do the calculation and we'd see why that's wrong. But it's sometimes quite difficult to get our heads around that. So let's have a look and see why it is not as simple as that. So let's work it out. How much is car B as a percentage of car A? Now with this one we used method B. Method 2, sorry, multiplying by 100. Maybe we could have a look at using the equivalent fractions method for this one. Okay, so I've got 5,000 over 4,000 because this time I've got car B divided by car A. So you can see the fraction, I've got 4,000 over 500 here. I've actually got the reciprocal here, 5,000 over 400. I want to make an equivalent fraction. So let's see what I need to do. I could divide by 10. That would give me 500 over 400. I might then be able to go, well, let's do it. Let's divide by 4. So we've divided by 10 to get from 5,000 to 500 and 4,000 to 400. And now I need to get, remember, my denominator needs to be 100. So I need to divide by 4. And I need to divide 500 by 4. A little trick for dividing by 4 is halving the number and then halving it again. So half of 500 is 250. Half of 250 is 125. So I did give you a bit of a clue, didn't I, by saying it wasn't going to be 120%. But look, it's really important. Car B as a percentage of car A is 125%. Okay, and in a classroom environment, we'd explore that and we'd look at why it's 80% when you do it this way, but 125% going that way. So it's just really good to just commit to memory that the difference is not the same. And the reason the difference isn't the same is because the denominator is not the same, but we could literally spend a whole lesson exploring that. I'm going to just do one more example before we come on to the second part. So let's just do one quick last example. Imagine I'm having a party. I've got 26 boys and 24 girls at my party. I want to know the percentage of boys and the percentage of girls. So the percentage of boys at my party is going to be 26 boys over the total number of people at the party. I need to add my boys and my girls together. The total number of people at my party is 50. And therefore I can use my equivalent fraction method, multiplying my denominator by 2 to get 100. Multiplying my numerator by 2 to get 52. So 52% of the children at the party are boys. What about girls? So we know I've got 24. Again, over 50, because the boys plus the girls gives me 50. That gives me 48 over 100 and 48%. Now, another really handy thing here is that everybody at the party is either a boy or a girl. So if I add all the boys and all the girls together, I get 100%. So I can now do my check and make sure that 52% plus 48% does indeed give me 100%, all of the children at the party. Right, let's move on to the second part of the lesson. To make some room on my desk, it's getting very messy. Right, so calculating. So this time we're calculating the percentage of a quantity. Calculating the percentage of a quantity. And I have to say, I have been looking at all the work you've been uploading, and most of it is fantastically neat with margins and dates, titles, everything underlined, set out neatly, learning bubbles where we need them. So I've been really impressed with the work that I've seen. Okay, so this is a really important thing. So I think this is going to go in a little learning bubble. Okay, so let's just write a sentence first. Right, if you can calculate these percentages, you can literally work out anything when we're trying to find the percentage of an amount, the percentage of a quantity. So if you can calculate these percentages, you can calculate anything. And these are the ones that I want you to memorize, okay? How to work out 50%, 25%, 10%, and 1%. And the reason for those is if you can work out those, then you can build those up to create any other percentage that you need. So for example, let's say the number was 30. So if the whole amount is 30, then my 100% is 30. So I would always start, if I know the total number of children in my class, for example, is 30, that's my 100%. 100% is 30. So if I want to work out 50%, I know that 50% is 15. What have I done? I've divided 100% to get 50. I've divided 30 to get 15. Okay, so for 50%, we divide by 2. Let's have a go with the next one. Okay, I'm going to write it out again. All right, remember, I'm still working with my 100% is 30. This time I want 25%. Now I might be able to just go straight in and divide by 4, but let's say that I'm struggling and my mind's gone blank. So I'm going to do exactly the same as I did in the first example. I'm going to halve 100 to get 50, and then I'm going to halve 50 to get 25%. Okay, so let's have a look. I've divided by 2 to get 15. Oh, now it's getting a bit trickier, isn't it? I've divided by 2 again. Okay, I might need to do a little bit of short division just to check, but half of 15 is going to give me 7.5 or 7.5. So let's write this down. For 25%, we want to divide by 4, or halve it and then halve it again. All right, there were 2 more I wanted you to know. I want you to know, I'm just going to split those up a little bit so it's really clear that we're looking at different examples here. So now I wanted to do 10%. Again, I'm going to start with my 100%. If my 100% is 30, and this time I want 10%. To get from 100% to 10%, I need to divide by 10. I need to do the same to both sides. So 10% of my number is going to be 3. I'm going to write my little key learning point here. For 10%, I divide by 10. We're nearly done. Let's do our last one. Now, there's obviously loads and loads we could do, but these are the key ones. If you can memorize these, they will really help you. The last one I wanted was 1%. Okay, that might be a little bit harder. We're going to end up with a decimal again, but we can start in exactly the same way as we did before. If we can't go straight to 1%, that's fine. We can do our 10% first, dividing both sides by 10. And then to get from 10% to 1%, I'm going to divide by 10 again. 3 divided by 10, I need to move my place value 1 to the right. And that is going to give me 0.3. So my last key learning point for this is for 1%, I'm going to divide by 100. And if we can commit those key calculations to memory, it will make it easier as we go through and work through things and check them. So that's the main method that I teach, to be honest, because it's the one that people find the easiest to follow. I'm just going to sort of do a quick example with it. Let's pick another one. So let's say we wanted 35% of 200. So the first thing I would write is 100% is 200. So then I might go to 10%. So I might do 10% is 20. Let's make sure we're writing that down as we did before. We've divided both sides by 10. Remember, I want 35%, so now I need to build it back up. So I could multiply by 3 to get 30%. We're getting close. Multiply both sides by 3. 30% is then going to give me 60. We're nearly there, but we're not quite there. So let's go back to our 10% and just write that again. 10% is 20. So if I want 5%, to get from 10% to 5%, I've had to divide by 2. So 5% is going to be 10. Let's have a look at the question again. I want 35%. So I want my 30%. And I want my 35%. So I can add these two together. 30 plus 5 gives me my 35%. And 60 plus 10 gives me 70. So there's my answer. Now I'm going to show you a second method, which some people prefer. It's up to you. But that one is it's a bit of a foolproof one, really. It takes a bit longer, but it works really, really nicely, and it's really intuitive as well. So the other way that we can do this is we can write our percentage as a fraction. Okay, so we've got 35 over 100, and we're multiplying it by the amount, which is 200. So you'll remember from when we did fractions, we've converted it into a fractions of an amount problem. So we've gone from percentage of amount to fraction of an amount. And now I can just multiply my numerators and multiply my denominators. But I'm tired, so I want to make it easier. So I'm going to cross cancel, and I'm going to divide 200 and 100 by 10. In fact, I'm going to divide them both by 100. So I end up with my numerator now being 35 multiplied by 2, and my denominator being 1 multiplied by 1, which gives me 70 over 1, or 70. So exactly the same answer again. Brilliant if you've got two different methods, because you can make sure that you haven't made a mistake. Probably just worth mentioning very quickly that bar modelling is also a really good way of representing some of these questions. So if I just go back to this one for a second, where you've got 35% of 200, okay, if I draw out, probably should have drawn it out beforehand, shouldn't I? If I just quickly draw this out for you. Okay, all right, so that's 200. So I could split it into 50% and 50%. Let's split it into a load of 10%. Okay, so I've got one bar that's now been split into 10 equal parts. So if the total bar is 200, then each of these little bars is going to be 20, okay? But remember, I've got 35%. I've made it a little bit hard on myself. So what I'm going to do is, instead of splitting this into 10 equal parts, I'm actually going to split it into 20 equal parts. So now each of these individual parts is going to be 10. So let's just very quickly write that in. As I say, I should have prepared this earlier, shouldn't I, for you? Okay. So I've got 200 and I've divided it into 20 equal parts. So 200 divided by 20 gives me 10. So I know that 10 goes into each of these individual bits, and I know that I need 7 of them. So have I got a highlighter pen handy? Okay, so I want 4, 5, 6, 7 of these, because 7 out of 20 is the same, is equivalent to 35%. If you don't believe me, let's write that down. 35 over 100. If I simplify this, I can divide the numerator and the denominator by 5. 35 divided by 5 gives me 20. I didn't have time to draw out 100, so I had to draw out 20. So 7 out of 20 is the equivalent to 35%. Okay, so again, when we're in the classroom, we'll do some more examples using bar modelling. Thanks very much.